Welcome back to my YouTube channel. Today I will solve a question of a JAM exams. Okay, question is given that V is a finite dimensional vector space and also given T is a linear operator on V and rank of T equal to rank of T square. Okay, then which of the following is necessarily true? Now solution. Here given rank of T equal to rank of T square. Okay, we already know that we know range base of T square containing range base of T. How? Now any x belongs to range base of T square. So this implies for some y belongs to V such that T square y equal to x by definitions of range base. Okay, range of T square. So this implies T of Ty equal to x. Okay, this, so that is T of Ty equal to x, but here linear transformation, this is the operator V to V, and T of y belongs to range base of T and range base of T subbase of V in codomain V. Okay, so this implies T of y also belongs to V, so this is written as sum y dash. Okay, so this implies T of y dash equal to x, so that is x belongs to range base of T since y dash belongs to V. Okay, so this implies range base of T square containing range base of T, that is range of T square containing range base of T for linear operators. Okay, so and also we know the result W is a subbase of V, and if dimension of W equal to dimension of V, this implies W equal to V. Okay, and this is equation number 1, and already given rank of T equal to rank of T square, and we also know that rank is a dimension of the range base, so that is here given rank of T square equal to rank of T, that is dimension of range base of T square equal to dimension of range base of T. So from one range base of T square equal to range base of T from this result. Okay, and also for nullity, we know that nullity of T square contain nullity of T. Okay, how? Since any x belongs to nullity of T, that is T of x equal to 0, and again operate T both sides, so we have T of x equal to 0, so this implies x belongs to nullity of T square, so that is nullity of T containing nullity of T square, and here given rank of T equal to rank of T square, so that is by rank nullity theorem we have n equal to, here given let dimension of V equal to n, so n equal to rank of T plus nullity of T. So here we have rank of T equal to n minus rank of T, nullity of T, and rank of T square, similarly we have n minus nullity of T square. So put this value here, we have n minus nullity of T, this equal to n minus square. So this implies nullity of T equal to nullity of T square. So using from this and this result we have from 2 we have nullity of T equal to nullity of T square, because a null space of T equal to null space of T square, because we know nullity is a dimension of the null space. Okay, so this is, we have this. Okay, so option 1 is true and option B is also true. Now option C, check option C. Now nullity of T intersection range space of T. Okay, now any x belongs to nullity of T, null space of T intersection range space of T. So we have Tx equal to 0. Okay, and for some y belongs to V such that T of y equal to x. Okay, because x belongs to null space of T intersection null space of range space of T, that is common element x. Okay, so this is hold. So this implies again operate here both side T. So T of y, this is equal to T of x. Okay, so this implies T square y, this is equal to T of x, and put the value of the T of x, that is equal to 0. So that means y belongs to null space of T square. Okay, and already we see null space of T square equal to null space of T. So if y belongs to null space of T square, so this implies y also belongs to null space of T. Okay, so this implies T of y equal to also 0. Okay, so from this equation number 3, from 3 we have T of y equal to x, that is x equal to 0. Put the value of T of x, so x equal to 0, and x here, x is arbitrary choosings. So we have nullity of T intersection range space of T equal to 0 vector. Okay, this is also true. So that is C option also true. Now option number D. For option number D, we choose example. Suppose this transformation T of xy, this is equal to x comma 0. Okay, where V is a R2 to R2 map. Okay, where T is R2 to R2 linear operator. Okay, so now find the rank of this. So first we find matrix representation. So T of 1 comma 0, this is equal to 1 comma 0, that is equal to, we written as this 1 dot 1 comma 0 plus 0 dot 1 0 comma 1. Okay, standard basis. Okay, and T of 0 comma 1 equal to 0 comma 0, that is equal to 0 comma 1 comma 0 plus 0 dot 0 comma 1. So now matrix representation is with respect to standard basis, we have 1 comma 0 and here 0 comma 0. Okay, so rank of this matrix, suppose this matrix is T beta. So T beta, rank of T beta equal to 1, and now again it's multiplying. Now T square beta, that is equal to, we know T of beta whole square. So this equal to 1 comma 0 0 and 1 comma 0 0. This is equal to 1, here 0 0 0. Okay, this again equal to 1. So rank of T beta whole square also equal to 1. Okay, but here nullity equal to 2 minus 1, this is equal to 1, nullity of t, this is equal to 2 minus 1, this is equal to 1. So this implies nullity of t strictly greater than 0. So nullity of t not equal to 0, null space of t is not equal to 0. Okay, so and we also know that rank of this matrix is also rank of the linear transformation. Okay, and also similar null space and also range space. So in this example we have nullity not equal to 0 vectors, null space is not equal to 0 vectors, so this implies this is false.